Okay, as we just saw in the previous video, what we have over here is we have a guy with a slingshot firing a little tennis ball, pulling it back 1 meter, and he's firing it over the 26 meter that 26 meter distance. So what we want to find is we want to find the spring coefficient when he's pulling back that slingshot. So there's a certain amount of data that we already know. Such as we know that the mass of the tennis ball is 0.058 kilograms, and we know that the time it takes for it to shoot over that distance is 1.5 seconds, or the distance it travels is 26 meters, and we know that when we pull back that slingshot, the compression distance is 1 meter. Okay, so since we have both the time and the distance in our given information, we can use that to find what the velocity of the tennis ball is. We know that the velocity is going to equal the amount of meters it travels over the amount of seconds it takes. So we know that it traveled 26 meters over an interval of 1.5 seconds. So we're just going to divide those numbers, and what we end up getting is that the velocity equals 17.33 meters per second. That'll come in handy later because we need to find the spring constant. And to do that, we're going to use our formulas that we know for kinetic energy and potential energy. And of course, according to the principles of conservation of energy, we know that kinetic energy and potential energy are going to equal each other. So let's plug in the formulas. We know that kinetic energy is 1/2 mv squared. Potential energy is 1/2 kx squared, where x is the compression distance. So now let's start plugging in our values. We're looking for k, remember. So we're going to try to isolate that, but first we're going to plug in everything that we have. So we know that we have that the mass equals 0.058 kilograms. We're going to plug that in for m. And our velocity we actually just found below. So we're going to plug that in. It's 17.33 meters per second. And we're going to set that whole thing equal to, again, 1/2 kx squared. We're looking for k, so we just have that there. And we know that x is the compression distance, which we found is only 1 meter, luckily, because it's really easy to square that, so it's just 1 squared. And when we go through all that, when we multiply 1/2 times 0.058 times 17.33 squared and divide that by 2, we find that k ends up equaling 17.42. That is our final spring constant.